In this problem, I'm given a tangent function, and I'm asked to locate two vertical asymptotes. And not only that, I want asymptotes with the smallest possible positive x coordinates. So we'll get to what that word jumble means in a moment. Now, if you're looking at something that says cotangent instead of tangent, okay, we'll get to that too. But you're going to have to go about, 5 more minutes into the video. Okay, I think this early stuff would be useful, but it's going to be a little different for you because you're dealing with a cotangent function. So let's do the tangent. And what I want to do to explain this is draw a parent function of a tangent graph. Actually, we're gonna transform a little. Tangent parent function is a little boring. I want a transformed tangent function. So this is a situation like this. You've got a tangent function. You have some asymptotes. But the thing was moved. It was moved off of the y-axis, and I got shoved over to the right a little bit. So this shift right here, the amount it was moved to the right is your phase shift. Sometimes it's the left, sometimes it's the right. In this example, we're going to just pretend this is what I've got. Now, I'm not drawing the equation up here. This is not that equation. Okay, this is just something I'm making up. The distance between the two asymptotes is called the period. So if you can see what the phase shift is at the center, you can see how to find that location to the right. All you do is you say plus 1/2 period to the right. And if you want the location to the left of that asymptote, you would say minus 1/2 period, assuming you know the location of the h value right there. So let's plug the stuff in that we have from the formula. I'm given right here the value for negative h. Remember, that's a horizontal shift, so you have to have this sign flip. So h equals negative 3 pi over 4, and you can read that straight from the equation. Period is not quite so easy. We have to use a small formula to calculate that, but it's really not bad. There's b at 1/2 value. B is whatever is multiplied by x. So period, if you remember your formula, is pi over b for tangents. That means pi over 1/2. And that means the period is 2 pi. So now we'll figure out the location of this asymptote. I'm going to call that x1. Okay, I'm going to say x1 equals h, the center of the tangent, plus 1/2 the distance between asymptotes. And that's just going to be negative 3 pi over 4 plus 2 pi. Well, I need common denominators. So let's not talk about 2 pi. Let's do 8 pi over 4. That's the same thing. I multiply top and bottom by 4. And now I get 5. Look what I almost forgot to do. Here, back up. What did I forget? I got the period right, but this is 1/2 times the period. Watch out for that. So this is negative 3 pi over 4 plus 4 pi over 4 equals pi over 4 is the location of the asymptote. Now, I want another asymptote. I want a pair of them. So one thing you could do is check to the left, right? Not a bad idea. I can just do the same formula except h minus 1/2 p, which is going to give you negative 3 pi over 4 minus 4 pi over 4. That was half the period. And I can tell right now this is going to turn out negative. And remember what this problem asked for. It wanted positive locations. So that's not so great. We're going to have to drop that one. Question is, what do we do? What do we do instead now? Because I don't want a negative asymptote. There's nothing especially wrong with negative asymptotes. It's just that that's not your answer for this question. So if you remember what asymptotes are, they're repeating features of a tangent graph. There will be another one. Just move one more period to the right. You can find the next one. So let's call this guy x2 right here. And think about what I just said. Move one period to the right. So we have x1 plus the period, which means pi over 4 plus a full period this time, because we're not going from the center. We're going from edge to edge. So that's going to be pi over 4 plus 2 pi. And if you do your common denominators, what you'll get is 9 pi over 4 for the location of the second asymptote. Great. Now, if you were doing a tangent function, you're kind of done at this point. If you were doing a cotangent function, I'm picking up right here with that. And let's change that to cotangent. And these answers are not going to be right for cotangent. Here's what you need to do. Think about it this way. I have a graph. And the phase shift of a cotangent function is not at the center. Okay, it's right here at an asymptote. Doesn't matter which asymptote you choose, just pick an asymptote, that's where the phase shift is. And if you have a function that looks like this, well, I mean, okay, cotangent usually looks upside down, but whatever. So we have some kind of cotangent looking thing. The distance between asymptotes is still the period. So this guy's actually easier than tangent because the location of that first asymptote is simply going to be the phase shift. And in this case, I haven't changed anything about the equation. So my phase shift is still negative 3 pi over 4. My period is still 2 pi. Well, what's the location of the first asymptote? It's h, easiest formula ever, which means it's negative 3 pi over 4. Obviously, the picture that I drew doesn't make a whole lot of sense. We're actually dealing with something more like this. Okay, I don't know, like that, where you have the first asymptote to the left of the x-axis. So that's not so great. It means our first number that we're getting here is not going to work for us because we want positive values. So let's just forget that one and say, here's our first number on the right side. So that means we have to add a period of 2 pi, okay? Which really means adding 8 pi over 4 if you remember your common denominators, which means your first asymptote is going to be located at 5 pi over 4. And the second asymptote, you guessed it, it's going to be one more period to the right. So that's going to be equal to x1 plus the period, which is 5 pi over 4 plus the period of 8 pi over 4, which means 13 pi over 4. So that's how you deal with the cotangent function. A little easier in my opinion. If you just remember that your phase shift, here's the crucial part. Phase shift for cotangent is on the asymptote, whereas with a tangent function, phase shift is at the center.